Nested loops. We're going to do chapter 17, 18, Decorator Observer. I will start it off. Let me share my screen. Application. Oh. All right. Readable?
Yep.
Okay, so here we go, Decorator Pattern. So this one is going to go reference.
You should change to presenting so it's stick on you.
Ah, okay. Good option. All right, this is going to conclude with the e-commerce case study that they started, the strategy pattern there. So the things they're going to cover in this chapter is they're going to have a new requirement, header, footer, show how Decorator handles this appropriately. Take another example, and this is probably the world's biggest, most prevalent example of Decorator pattern in the wild, Java IO. We're going to talk about some key features of Decorator pattern and some of Al's experience using it in practice, and then explaining how it's not a linked list. So we're going to go back to the case study. So this has to do with sales orders and sales tickets. And if you recall, before we were doing stuff for taxes and trying to be flexible there. So the overall UML here is we have a task controller, which calls sales order. And sales order is the thing that we care about. We process. We're adding this new thing, printing a ticket. This is a little UML comment diagram here, print ticket. Before I just talked earlier about how we have a calc task. So at the left, there's, calc task, US tax, Canadian tax, German tax, stuff we've done before. The new functionality called from sales order print ticket is delegated out to a sales ticket class. It turns around and calls print ticket. So in general, I kind of find that a little redundant. You have a ticket. Ticket.print ticket. It's like, oh, you already know it's a ticket, so why shouldn't it just be print? But that's a different flavor. So the new requirement here is now we need to have a header. So in the process of writing, I get a new requirement because this always happens to us, and that's why we like OO and design patterns. What could we do? Well, the easiest thing is to put a switch in the sales ticket. And again, the header is variable. That's what makes it the key difference here. So if he says, I have a system for just one company, and that may indeed be your problem, then it's easiest just to add the control of headers and footers to the sales ticket class. So he's got a 17.2 diagram. Again, we have the sales order, has a sales ticket. He's delegated out header and footer, kind of single responsibility principle in the subclasses. And in the comment, he has here the little code. If you want header info, call the header print header method, then call the print ticket. And if you want footer, call the print footer. Now, the problem with this is if you have more than one case or company or kinds of headers or footers, it's not flexible. So, here again, he says he's got the sales ticket class and he's got some flags. Do we print header or footer not? And this is fine if the headers don't change or you don't have a lot of options, but actually probably could have no options, not too well. Once we have many different kinds of headers and footers, then he might consider strategy for these. But what happens if I had to print more than one header? So this is, if there's only one, that's the key here, I can have a strategy and rotate out the strategies. But what if I need more than one printer? Or what if the orders need to change? Or again, the combinations are different. More than one header printed, more than one kind of header you could pick from, or footer, or order. Maybe I have the footer first, which of course doesn't make sense as footer, but he's just saying he's mixing the orders. So once you have a lot of combinations like that, then pattern we're looking at is Decorator. So instead of controlling by adding a control method, we control it by chaining. And this is really the key here. It is the chaining of things, of objects. It gives the what the decorator brings. So the highlight point I have here: separate the dynamic building of this chain of functionality from the client that uses it. So as we've seen in a lot of the earlier OO patterns, we unify the interface. So instead of having conditionals here or there, you just call this object, and then the conditionals are wrapped somehow inside the pattern here. So the key thing with the decorator here is we don't build it. We just have this object we call, which comes back to, I separate the dynamic building of the functionality from the client that uses. The client doesn't care. He just calls an object. And then we separate the building of the chain from the chain components. The components also should not know how they're being used as long as they're called by their interface. So components don't need to know anything. And so you can see the coupling for this is the client is decoupled from the details of what it's using, as well as the components that make up the added thing don't need to know about each other either, which always makes it then easier to plug and play these things. So now we're going to go by the Gang of Four intent, and it says, according to Gang of Four, we are attach additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. So when he says dynamic, and this is something that Ruby in being able to monkey patch and change, you can do some patterns that you'd have without the kind of things here, which for like Java and C# you have to do a certain way. But still, it's a good pattern to have. But some things you can do differently. But the key thing with dynamic is the point meaning here. Dynamic is not in the Ruby kind of like, oh well, we just change this at runtime. You construct different decorated objects, but again, to the client, you only see one object that you call whatever function on that object, and all the decorator hides the fact. But at real time, you can change some options and generate a custom decorated object, and then have something at real time. So this dynamic is a little different than how we look at it in Ruby. So how does this work? So the chain of objects, I talked about earlier about the chain. So you have a decorator, wraps another decorator, wraps another decorator, and what they're using here is the concrete component, which is ultimately the original thing that we're decorating. So you can see that this is a chain of objects, and now we're going to look at a class diagram with a little bit more of the terms. So we have a component. Oh, sorry, because it's one image. We have a component. Can you guys actually see where my mouse is when I move it around? Well, fortunately, I have this feature in OS 10, or not OS 10. This thing that I added because when I can't find my freaking mouse thing on my gigantic monitor, I use that. So we have a component with operation. There's the concrete component. That's what we're actually going to decorate. And we have a decorator. So both of these inherit from component. So they all support this magical operation, which is this interface I'm talking about, where my client just grabs an object and then calls operation on it. So under the decorator, we can have a variety of concrete decorators. You know, I guess this is the abstract decorator, the concrete decorator, and you can see they all have the function. In decorator A, we have different state, which maybe makes the calculation different, or in concrete B, we have different behavior. So however you want to change it, you're always running this original. Oops, sorry about that. I just hit a space. I don't know what happened. Okay. Yes. So the client's always calling this operation, and you might have to add some things to it. And again, there's usually a core one that you're adding to, so you can sort of see, and then it's all hidden by this one interface. All right, and then I guess he's going to say what I just said. Concreator B performs operation, then calls. Okay, yeah, you can sort of hear. Here he is explaining. Sorry again, I'm going to use this one. It performs its operation, then calls the operation method in decorator. This is, calls. And it's going to speak to some questions and some things related, but we're basically decorating. We're adding stuff to something that exists. So let's apply this to the case study. So now that we know something about a decorator and how it might work, we're going to flesh out. So the sales ticket is the concrete component. The concrete decorators are the headers and the footers. And let's go look at our new chart. So component, print ticket is the method that we're expanding. Sales ticket is the concrete one. The ticket decorator is the one that's going to decorate that one. We've got a little complex in this particular implementation. Check if my component is not null. If it is, call print ticket on that one. So now of the ticket decorator, here are some options. I got header 1, I got header 2, got footer 1, footer 2. And the basic way the headers do is they print the header first, and then they call the thing I'm decorated, which in this case he called out ticket decorator print ticket. So my method first, then the thing that I'm decorating. And then the footer is the reverse. Call the thing I'm decorating followed by my footer. So as we instantiate a pattern, we might wrap it like this. We have the client who uses this thing that responds to print ticket, which happens to be a header wrapped around a footer around the sales ticket, which is ultimately what they're calling the concrete decorator. So again, the client only sees one object, and this chain could be arbitrarily long. It could make it glow in the dark, and whatever. It's all things that you could add that. So how does it work? It's actually pretty simple. You just wrap your trailing object. So here's the code thing, and again, a decorator wraps a trailing object, and it either puts it before or after, or both. It doesn't matter because you're decorating. The header footer kind of shows you cases of before and after. So we'll go through the code, which I believe spans 2 pages. Actually, I don't know if I can see all the code at one time. So we have a client, and the only thing we know about the client is that he gets some components from a factory. So he never needs to know what he's getting or what it is. So at the higher level, we have a component, abstract class there. And again, this is the interface that we're duplicating everywhere. Sales ticket is our concrete component, and then print ticket actually does whatever the printing actually is. And then this is the decorator. We'll go with the base class. Ticket decorator explains this one. The way he set this up is he calls a trailer. Has an object here, and then you construct it. You inject the component in the constructor, and if you have one, it makes kind of odd to me that we have one that doesn't have a trailer. Like, why would we give you a decorator that's empty? But he handles that case. If I actually have something to decorate, then call the print ticket on that. So then the general pattern for header is that we extend the decorator class, and you can see the constructor here takes the component that you decorate. And over here, it's I do my print code first, and then I call trailer. So this kind of allows these decorators to not even know that the method's called print ticket. That could be good. I think it's overkill for this example, but for something that's general use, that makes sense. And I probably wouldn't have jumped that far until I saw the need for such. And header 2 is the same deal, but they have different print before they call the trailer. And the footer down here is the opposite, same basic structure. I call the trailer, and then I put my own printing code. So you can see how in the headers, I do my stuff first, then I call the thing that's decorated, and then the reverse is here. I call the thing that's decorated, and it's down there. And then the factory here, here's an example factory. I take a sales ticket, which gets wrapped. I wrap that with the footer, wrap that with the header, return this, doubly decorated object, which again, the client doesn't care. He just turns around and calls print ticket. And that's pretty much what it says. What happens in the code? Well, if you want it to look like header, sales ticket, footer, and this actually is inlining all this, but return a new header, wrapping a footer, wrapping the sales ticket. All right, so as we come down to this one, okay, creates a header, trailer by footer, yeah. If you want to look like this one, so now you can wrap 2 headers. Though I have to wonder if this is actually the right call him. Yeah, call me, call him, which says call him, and then print my stuff out. So if you want, this is the case where he expanded. Now I have 2 headers for some reason, a sales ticket and footer one. And again, 2 different kinds of headers. And so that really shows the flexibility. If there was only ever one header, one footer, You could do strategy. Decorator allows you to put this multiple headers and whatnot.
It seems like that sentence there that it creates the footer object trailed by a sales ticket object is inaccurate. It's actually a footer object preceded by a sales ticket object, right?
Well,
for that line.
This is how it prints, but this is actually how
Right.
it's constructed. I would say this is accurate because it describes this code.
I see.
Right. So this is how we construct it. But because this guy calls him first and then runs his stuff, that's kind of how this has to be constructed.
Maybe trailed by is not, because it's really like.
Yeah, this one seems in conflict with this. But it's
like it's really wrapping the object, not.
You know, I don't remember the original Gang of Four language. I don't remember this being exactly the language that I recall. But
right.
I did not bother to pull, which I believe actually is in my bookshelf. Is that true? Or it might be my bookshelf at home. I have the Gang of Four somewhere sitting. But yes, I can see you being thrown by the words. But I think this sentence is meant to refer to this code. All right, decomposing by responsibility. So Decorator gives you, it breaks the problem in two parts. One, how to implement. With this decorator pattern, now we know how to add arbitrary functionality to this one. And then we also know how to organize. And he says here, I think this organize objects is the code thing. Again, this is the organization. And we get a problem. How do we solve flexible this? And by the way, this is how we organize that code-wise. So, and I talked about this earlier, separates decorators from the object that determines how they're used. And again, cohesion, because all the decorators are concerned with the functionality adds. It can be focused on that one and not how. For whatever reason, my header could be at the end. Of course, it doesn't make sense in this case, but you can see this functionality there. It also allows you to arbitrarily reorder. So yeah, it's flexible. So now we're going to come down to probably it's very flexible, but I got to say it's kind of annoying.
I actually have the Gang of Four book right here, and they alias this as also known as wrapper. The pattern is also known as wrapper.
Yeah, that's kind of a bad, because there are a lot of patterns that are wrappers. Wrappers is easily generalized to a lot of cases. There's like 3 or 4 patterns that wrap classes, but they have different intents. Usually they have slightly different implementations, but they always have different intents. Okay, so Stream.io. So common pattern is Stream.io, aka Java. So they're going to talk a little bit about this. He wants to limit this to input because output works the same basic way. So he says, once you see one way, you know the other way. So the example here is, I can read from a number of different things, but I want to treat them the same. I could be a file. I could read a socket, and then maybe I need to decrypt something. I could read from a file. I have to decompress it. I could read from a string. So a lot of these you can sort of see. You can already see the decorator. A something and a something. A something and a something. A file that I decompress, and then I decrypt it, right? He's kind of feeding into, hey, why is decorator good? Well, I have these things that I kind of modularly construct. So now we have this table split on 2 pages. Sources, I could have string, file, socket IO, serial port, parallel port, keyboard. Oh, sorry, I hit the page. Buffered input, things I need to handle. Buffered input, checksumming, unzipping, decrypting, selecting various stuff. So, and languages reflect this. I don't know exactly that comment there. So, if you use an OO language, you can have your source and behavior derived from concrete class, common abstract class. Each behavior can give it its source prior to behavior in the constructor. So basically, he's going back to chaining objects that all derive from a concrete component where the behaviors are put in all the decorators. So in the case like this, the word concrete component is now a misnomer because it's actually abstract and concrete versus abstract is more important in statically typed languages. Ruby, we generally, it's more just conceptual and rather than a particular implementation a lot of times. And down to or Java, where you have interfaces, which actually mean a specific thing in Java. So he's talking a little bit about how the language for the pattern might not match the conceptual OO structuring language. All right, so now we're going to read from a file, decompress the input, and then decrypt it. So how would we do that? We'd build the decorator chain by making the file object. This is what we ultimately decorate. Pass this to the construct of decompression. So now this will deconstruct that, and then pass that to a decryption object that will decrypt the decompressed thing from the file. And so now again, the client just calls some input and calls whatever the read function in, which does these three things. So if you need to get the input from a different source, you make a chain using a different. So you could also have a decryption decompression stage and then have it come from a socket, for example. And then talks about the stream zoo. So yes, Java is notorious for this, and it's super flexible, but sure a lot of code. Sure a lot of code. Anyone who's done Java stuff has done, oh, buffered input, file input, and you just buffer these things together. Ultimately, this gives you a lot of flexibility. Okay, field notes. So using decorator pattern, just the chain, instantiating it. So the power is that the chain can be decoupled from the client. So the client code then is always easy. And typically, you know, and especially you always see this in Java code, typically use factory objects to instantiate. So you get a factory, you call the factory, and it gives you, you know, maybe something that could be like 5 decorated objects, but you don't care because you just turn around and you call the object. You can use decorators in testing. I kind of wish you put a code test for this one, but he kind of like wraps his pre and post tests in these decorators and then uses that. So during testing, the first object in the case can do extensive tests of preconditions prior to calling a trailing object. Immediate after trailing object call, same thing can call post conditions. So that's kind of neat. So I can keep each test in a different decorator and chain them together. That seems like an interesting thing for JUnit style testing. So here's the typical breakdown of the decorator key features. You know, the key thing again is additional responsibilities dynamically. The general problem is that you have something that has the basic things you need, but you want to add additional functionality. He calls out before, after, you know, and again, that IO does this a lot. So what's the solution? The solution is this gives you the ability to extend the functionality without having to write subclasses. And again, this fits in with the whole composition. At a slightly different, they always say prefer composition to inheritance. This is something that you're literally composing things out of many, many things. But again, we still implement that same interface. So we still inherit. We're not putting it in that class. We're single responsibility principle delegating that to these decorators that we can compose in very flexible, quote unquote, real-time things there. So it's made up of concrete component that has decorators, and decorators wrap that, and sometimes classes deriving from concrete component, like most of the examples we showed, those decorators also derive from this, so they have the same interface. So he says technically this is not concrete, but abstract, but I don't know that it's important to nitpick on the exact terminology. You understand the basic structure, that there is something that gets decorated, and these decorators have to have the same interface. And again, that's a loaded word if you're talking Java. Consequences is now we have small objects for each. That's nice. Cohesion, single responsibility, the ability to dynamically add the functionality before or after. You know, and this says again, you know, we have one final thing that gets decorated by this chain, and the implementation is, I think we already talked about in multiple cases. So here's the general picture. Here's the component, the interface, the component that we're decorating. the decorators that, of course, inherit from this. And again, this goes back to this line about, well, sometimes they inherit from content component. This is so we have the same interface. And then we take any number of decorators, which at some point wrap or trail. The trailing decorated component is here. So the essence of this, and this actually went down when I was talking about wrappers. It's like, oh, the structure's not the pattern. There are so many patterns that wrap other objects, but the intent and the usage is different. Sometimes the class diagrams look identical, but the intent and the benefits are somewhat different. So,
yeah. What's interesting is in the Gang of Four book on the intent for decorator, they have the same thing that he said in intent to attach additional responsibilities to an object dynamically. But they also add on that decorators provide a flexible alternative to subclassing for extending functionality. And that's kind of the way I've always thought about decorator, is that you, most of the time, you're just adding a couple methods, but you don't want to modify the original object. Yeah. Or you're adding some new functionality.
And that's more of, because like, back to this diagram, we are in fact subclass. If you literally look at the word, we are literally subclassing this to add functionality. The difference is we're not subclassing from below this guy. What we'd take this and we'd have the header printer thingy. We don't put it here. We actually subclass over here and then compose it. So the real flexibility is technically we are subclassing, but what normally is I take this and I subclass here and I subclass here and I subclass here, which then now I have to have a tree of explosions if I have like 12 variations, whereas over here I might have 3 or 4 here that I can create the 12 variations just by changing the decorator factory. So yes. So going down to here, blah, blah, blah. Okay, so variety of optional things, proceed or follow. And this looks just to me like he's reading. What if you want to encrypt, compress, translate, blah, blah, blah. Okay. We already saw this is great for the IO pattern. Oh, this is the part he's calling it the link list. He says we might implement this. The way you hear this description, you might say, make a link list of optional functions that end in the transmission object. The decorating object should have the same interface. So this is a bad idea because suppose the decorators are created by. So this is when we scale to something for different development groups. And then additional functionality. Let's say state. There's certain exceptions that you need to handle. Who catches the exceptions? So, and if I think of Al's perspective as an agile trainer consultant, this is something that's, this is a scenario he sees. I got different development groups, and we write some code, and who knows who's going to catch which exception? Well, we can hope that each one would catch it themselves, which we can never guarantee. But what if they don't? What if it's thrown in the code and catch it? Well, then the whole system crashes now. And again, this is a consultant who deals with a company with several development groups sharing code, And then, well, one solution is the client catches this exception. But then we lose a bit of the decorator pattern because now the client needs to know something, whereas before it just needs an object that it calls on. And then here's a pattern solution. Well, you could have a collection object, which puts us kind of into the composite pattern. That has the same, that's exactly. Collection object has the same interface as transmitted object. That's almost literally the definition of composite pattern. This calls calls a decorator and catches the exceptions in case they don't. So this is having a wrapper that does exception checking, right? And this one allows decorating objects not to have the same interface, but yeah, we're starting to diverge away from the decorator. So here are the forces for decorator pattern. Several optional functions exist. They may not follow all the rules. You want to invoke these in different orders without adding complexity or intelligence to the client object, and you don't want the application knowing which of these to use or even that they exist. So we can see that thinking about decorator pattern like this makes a difference between the purpose of the decorator pattern and the implementation. And we talked a little bit about that earlier, where there's certain things that we want, and then this is how we do it. So again, I guess if repetition is the magic to remembering, again, the decorator is something to add functions, possibly plural, to an existing functionality. It requires building a chain of objects to give you these behaviors, and ultimately decorators know nothing about how they're built or how they're used, and the client needs to know nothing about these and just how they call it. So now we see who's paying attention. What does each decorator object wrap? Diego.
Let me unmute.
Yes, I'm
So they each wrap their trailing object.
Yes, each one wraps another one. So number two, what are two classic examples of decorator? Scott.
One of them is the use of them for I/O, and the other one is, the first example is using it to augment what is output or displayed on a screen or a form.
Yeah. So something that's often used as decorators for GUI things. Like you might have a window, and then scrolled window is something that you can have any window that meets a certain interface, and you put a scrolled window around it, and that would decorate it. All right, number one. How does the decorator pattern help decompose the components? Alex. Or decompose the problem. Decompose the problem.
Looks like maybe your mic's not working.
Oh. You talking? Can't tell.
Yeah.
Can't tell. Okay. I will do the voice of Alex. Yes. So each decorator, and I have not spent any time trying to do an Alex imitation, so apologies there. Yes. So each decorator encapsulates its own thing. Well, it gives you a number of things. It gives you a structure. It gives you a structure. How do you compose things? You can wrap decorators arbitrarily to have any amount of functionality in any order. It also helps you separate the client now needs to know nothing except that it's an object that it calls, and the objects themselves don't need to know about each other. They can just focus on decompression or encryption or whatever it is that you're decorating there. All right, number two, the structure is not a pattern. Statement was made during the essence. What does this mean? Why is this important? Don.
I'm trying to think back to when he said this. Maybe he's just saying that the idea of the pattern is to extend the functionality, not to necessarily nest the objects in a certain way.
Yeah.
Something like that. So that the exact implementation is not the purpose or not the point of the pattern.
Right. So,
by the way,
it's I think as coders, if you get a pattern, I think our instinct is show me the class diagram, right? And if you like page to it, and if I recall, the Gang of Four is not UML; it predates UML, so it's like OMT, I believe, is the diagramming thing. So the thing is, you want to look at that one, and then sometimes you confuse. Oh my God, this pattern is the same as that pattern because it has the same structure. It's the design patterns are really all about what your problem is in what context and what trade-offs you're going to get what you need to have, right? And so the intent, in this case, the intent is I have variable behavior that I want that wraps something that already exists. I have variable behavior I want to add to something, and because it's variable, what can I do? And then what can I do ends up giving you, well, not only do you get variable behavior, but now your client code is super simple, and because you've SRP'd your functionality, individual decorators, each one of those are super simple and can be oblivious of each other. So you get all this better code stuff through this example. So again, structure, again, I think that, well, in my mind, when I see this sentence, go, well, don't just look at the class diagram. There's more to whys and whats as opposed to this particular structure. That's kind of what I think. All right.
So I think in the Rails world, one Let an example. It probably doesn't follow the same structure. I'm not sure, but I don't think it does. It's rec middleware, because they all call each other and they augment and decorate
Right.
whatever it is. But like the structure is like, they each are like single classes.
Mm-hmm.
That they just have the similar interface. They have an initialize and call.
Yeah, and again, Ruby with duck typing, you don't have to inherit anything. You just have to implement the same method with the same signature, and you can do it. But yeah, actually, Rack is a good decorator for Rails, for Ruby web programmers. That's probably back to this question of two classic examples. Oh, I think Rack middleware fits that quite well. All right, opinions. Why do we think the Gang of Four calls this pattern the Decorator? Is it an appropriate name for what it's doing? Why or why not? Anyone have an opinion on that?
Oh, I do. I don't have an opinion very often, but sometimes I do. I think the name Decorator implies that the decorators themselves don't know much, if anything, about what the internals of the trailing object are. In other words, they decorate. They don't change what they're laid upon. They just decorates kind of around it, is the way I see it.
Yeah, I would agree with that last sentence. All right, I saw Alex unmute. Did he have an opinion? No, but you have broken audio still. So all right, so I will synthesize what I'm going to say is Alex's opinion. So I think Alex is going to say decorate simply is just like real decoration. You're just adding stuff to something that exists. You have a room. I decorated by putting paintings up and
hot glue stuff to it.
Yes, or in our case, we just litter magazines all over the place. That's how we decorate our office here. So, okay, some people like to think of patterns as recipes. What's wrong with this? Anyone have an opinion on this?
Maybe it goes back to the structure is not the pattern thing. That there's not always an exact set of steps you follow.
Well, and I realize this depends on people, how you cook. When you do a recipe, do you follow the exact order, the exact ingredients? Or, some people are, I follow it to the letter. And some people are, I look at it, and I have an idea of what I want to make. And arbitrarily, arguably, the second way is kind of closer to reality. You look at the pattern, and it's basically what you want to do, but the way you want to do it is not necessarily exactly the same as that. So I almost think like, well, this depends on how you cook. If you are a recipe Nazi and you must do it exactly 100% to the recipe or die, then yes, then this is bad, because the patterns won't always work that way. All right, that concludes mine, part 6. Do we have time for Don, or should we push it off?
I think maybe push it off, because I don't think 15 minutes is going to be enough.
Okay, then I'll talk about this. So in this part, we're going to talk about patterns containing variations by illustrating different variations that can occur besides functionality. So moving forward, next time, Don will do observer, how to contain variation in both which object wants to be notified and under what circumstance. That's this variation. So we talked about variation of functionality. This is now notification and circumstances of notification. Template method. This is a great pattern. How to eliminate redundancy and encapsulate a procedure to be followed, and then how to have variations in this. And I don't remember if Andrew remembers. I told him at least once or twice, hey, you could do template method for whatever it is that you were trying to do.
Yes.
So
I didn't remember.
It's real handy for that kind of.
I would take it if it's open.
Oh, okay. Well, if you want to do it for that one. All right. Well, then I guess that wraps up. Is anything else to say? We're done. We're done. Any parting words from anyone else besides me? Okay.
Is the decorator pattern kind of functional in a sense?
Functional programming in general is kind of decorative. If you just look at like the Ruby iterator stuff, bank.select.map.join, that's a very Ruby iterator thing. But that's if you look at a lot of functional, like Lisp. Lisp does that completely. Lisp is completely wrap, 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 wrap. You know, each one does something with the results. So decorating is almost a default of a lot of functional styles of programming. So yes. Okay. Well, cool.
Interesting. Elixir has a method style called stub, and it seems like it's 50% Elixir code is built with stubs, and they're just they're basically chaining the HTTP gang, and that's what they do instead of callbacks. A lot.
Yes. Well, that's because JavaScript is asynchronous, and you have no choice. Okay. Well, cool. Then we will readjourn in 2 weeks. Thank you for coming, Nessie Loop. Enjoy your day, and I hope Alex gets his audio fixed. Otherwise, we got to work on our lip reading. So, and maybe that'll be a future study group. Lip reading on Hangouts for fun and profit. Okay, cool. Thank you.
Cheers.
Thanks.